June 2020, paper 6, variant 1. The first question is about chromatography. A student uses colored inks to make a chromatography experiment. Water was the solvent. And then he shows you how the student set up the apparatus, and he wants two errors. Of course, the first error is that the solvent line is above the baseline. This means that the samples will dissolve in the beaker, not on the chromatography paper. Yani they will not appear on the paper, they will dissolve in the beaker. So this is the first mistake. The second mistake is that the baseline is drawn in ink, and this is a huge mistake because ink is soluble and will interfere with the results of the chromatography. Okay. B. I. Which ink contains the greatest number of soluble dyes? Of course, it's the black one. It contains 3 soluble dyes. Which 2 inks are made of a single soluble dye, the yellow and the blue one? Triple I from the chromatogram, it is not possible to tell if the red ink contains different dyes. Yes, the red ink didn't separate, okay? So he wants a suggestion how the experiment could be changed to find if the red ink contains different dyes. The answer simply is to use a different solvent or an organic solvent, or use ethanol instead of water, because it seems that the substances in the red ink are insoluble in water, and therefore to know how many substances are present, you need a different solvent where they're soluble in. Question 2, it's a reaction between sodium carbonate and hydrochloric acid. It's always useful to write a chemical equation so you can imagine exactly what's happening. Of course, the products are sodium chloride, carbon dioxide, and water. Sodium carbonate solutions are E and F. When you have the same solution given 2 different colors, this means that, given 2 different symbols, this means that they have different concentrations. And then he did a titration experiment, and he wants you to take the readings. He used an indicator called thymolphthalene. He used a measuring cylinder, which is a mistake. He should have used a pipette or a burette to add the solution. And then he wants the readings, 10.2, 0.0, and 10.2. Don't forget that all burette readings should be taken to 1 decimal place. Experiment 2, the final burette reading is 25.9, 5.5, and the difference is 20.4. Okay, you should immediately notice that the difference is the double. We needed double the amount of hydrochloric acid in experiment 2. Experiment 3, the final burette reading is 33.0, the initial is 2.4, and the difference is 30.6. Okay. So B, what color change is observed in the conical flask in experiment 2? We need to go back to experiment 2. Of course, he's adding sodium carbonate in the conical flask, and then he added drops of methyl orange. Methyl orange gives a yellow color with sodium carbonate because it's a base, and at neutralization point, it will become orange. It will turn orange. Red was also accepted in the mark scheme. Question C, compare the volumes of dilute hydrochloric acid added in experiment 2 and 3. Explain any differences. Of course, the volume of HCl in experiment 3 is 1.5 times more than experiment 2. You must always find a mathematical relationship between the volumes. It's rarely enough to say more. يعني دايما بيبقى عايزك تقول twice, double, half, 1.5 times. And to get this, you simply get the 2 values, 30.6 and 20.4, and you divide the larger number with the smaller one, you will get the ratio between them, or how many times is experiment 3 more than experiment 2. The reason is that solution F is more concentrated than E, and this is a very important question. He always gets this question. You have 2 conical flasks, you have E and you have F, and you're adding the same acid from 2 burettes on both solutions. Okay, you required 20.4 centimeter cubed of the HCl to neutralize E, but you required and you required almost 30.6 centimeter cubed to neutralize F. This means that F was more concentrated as it required a larger volume of HCl. Then he wants the simplest whole number ratio of the hydrochloric acid between experiment 1 and 2. Of course, it's 1 to 2. All you need to do is go to the readings. Here it's 10.2 and here it's 20.4. So you say 10.2 for experiment 1 and 20.4 For experiment 2, you get the ratio simply by dividing by the smaller number. It will be 1 to 2. What volume of HCl would be required if experiment 3 was repeated using thymolphthalein indicator instead of methyl orange indicator? This is an important question, okay? Experiment 3 was done with methyl orange, but to know the effect of thymolphthalein, you need to look at experiments 1 and 2. Experiment 1 and 2 were the same exact experiments, except he used here thymolphthalein and he used here methyl orange. And immediately it required twice the volume, okay? It immediately required twice the volume of HCl. يعني with thymolphthalein, he needed 10.2, بالmethyl orange, he needed 20.4. Now he's asking, okay? Now he's asking back. He already did this with methyl orange, this one, experiment 3 with methyl orange. And he's asking, what if I repeated it with thymolphthalein? طب ما احنا from experiment 1 and 2, we knew that methyl orange requires twice the amount of thymolphthalein. صح؟ طيب, if he needed 30.6 centimeter cube with methyl orange, يبقى he will require كام with thymolphthalein? Half the volume, 30.6 over 2, which is 15.3 centimeter cube. Take care, the units are important. They're worth a mark. Fi, he rinsed the conical flask after the first experiment and after the second experiment. Why? To remove residues from the previous experiment. He's just removing the remains of the previous experiment. Then he's asking, why does it not matter if a little distilled water is left in the flask after it has been rinsed? Because it will not affect the volume of E or F. كده كده he already measured the volumes of the sodium carbonate solution بmeasuring cylinder برا الconical flask, so it will not affect the volume of E or F because it's a small amount. G, state 2 sources of error in the experiment and suggest an improvement. Of course, the most obvious one is using a measuring cylinder. He should have used a pipette. يعني a pipette here is more preferred than a burette because he already used the burette in the experiment. He didn't repeat, and it's important to repeat and take average بالذات في titration experiments to minimize error. He might have missed the endpoint, and this is an important error في موضوع titration. One of the errors you can say is missing the endpoint or going past the endpoint, and the solution is adding the solution from the burette more slowly. Add the solution from the burette more slowly to take care not to miss the endpoint. Question 3, cations and anions. Solid J and H. G was copper carbonate. So the cation is copper, the anion is carbonate. And first of all, he added sulfuric acid and a gas was tested. Acid على carbonate means carbon dioxide. Bubbles will be produced. Gas turns lime water milky. You can take the 3 marks for bubbles and lime water and milky, but also another answer that could be said is the solution turns blue because copper carbonate reacted with the sulfuric acid he added and formed copper sulfate solution, which is a blue solution. As you know, you can take the 3 marks. Any 3 from these 4 points takes the mark. Identify the gas produced in A. Of course, it's carbon dioxide since carbonate is present. Then he added aqueous ammonia. Aqueous ammonia is a test for copper ions. It gives a blue precipitate or a light blue precipitate, which is soluble in excess, giving a deep blue solution. A deep blue solution is worth a mark. Blue precipitate is for a mark. Is for 2 marks. Tests on solid H, yellow flame when he performed a flame test. This is sodium. Condensation appearing near the mouth of the tube is a very important point, which means that the solid was hydrated, okay? And then he dissolved the solid in water. He added nitric acid followed by silver nitrate, which is the test for halides. The solution remained colorless, so we know that there are no halides. مفيش halides, nothing happened. Test 4, he added nitric acid followed by barium nitrate. White precipitate was formed. This is the test for sulfate, so we have sodium and sulfate. D, what conclusions can be made from the result of test 3? That no halides are present, of course, because the solution remained colorless. And what conclusions could be made from test 1, 2, and 4? Of course, test 1 is that sodium is present. Test 2 is that this solid is hydrated. Test 4 is that sulfate is present. So overall, we can say hydrated sodium sulfate. Or you can write the formula of sodium sulfate and take 2 marks. Finally, the experimental investigation. Cobalt, manganese, and nickel are metals. They react with acid, hydrochloric acid, to form hydrogen gas. Whenever you see a gas formed, immediately think about measuring its volume as a way of knowing the rate of reaction. Plan an investigation to find the order of reactivity. You're provided with HCl, samples of the metals, and common laboratory apparatus. Your plan must make it clear how your investigation will be a fair test and how you will use your result to place the metals in the order of reactivity. He wants a conclusion and he wants you to make a fair test. Fair test يعني لازم تفضل تقول same. What will be the same in the experiments in order to ensure it's a fair test. طيب. I like to do it this way. First of all, you talk about a metal and then you repeat the same experiment with the other metals. في ناس بتحب تعمل 3 metals مرة واحدة في نفس الوقت. It's fine. But I do it this way. Add, and you can say any amount, 5 grams, for example, of cobalt to powder to 25 centimeter cube of HCl in a conical flask. Okay. Measure the volume of gas produced per minute. Take care, you're measuring the rate. فلازم تقيس الجاز per minute. You start the timer immediately when the solid is added. يعني take care, you need to tell him and you will start timing أول ما الsolid يبقى added in the acid. Repeat with manganese and nickel using the same mass of the metal, the same surface area of the metal, the same volume and the same concentration of the acid. كل حاجة تفضل the same, okay? You can say also the same temperature of both experiments. It could take a mark. And then you need to say that the metal that produces the highest volume of hydrogen gas per minute is the most reactive metal. The largest volume, يعني ده most reactive, okay? The conclusion is essential. You must say the conclusion for a mark. You must say you can take up to 4 marks على موضوع الفير test. Same mass, same surface area, same volume, same concentration, same temperature. You can take 4 marks and you can take the final mark من setting the experiment correctly. إنك هتحط الميتال to the acid in a conical flask and you'll measure the gas per minute. ممكن تقول كمان by a gas syringe. مش هتخسر حاجة to say the experiment apparatus. طيب, there are other ways for doing this experiment. المهم انك تكيب الفير تيست زي ما اتفقنا. You can measure the time for the solid to dissolve. You can measure the mass loss. You can measure the temperature rise. There are many ways to measure the rate, although I always say in the easiest, the most straightforward one, the most per minute. This was June 2020, paper 6 variant 1 by